Kiddos, hope everyone's doing well. This video, we're going to talk about this particular diagram for a while, and we're going to talk about parallel lines and the angles that are created. And so today in class you did a project using Sketchpad, and let's just quickly reproduce that. So you created a line here and then a point not on that line. So you could, through that point, create one parallel line through that point. Okay, so I'm constructing a parallel line. We did this today in class. Here are two parallel lines, right? Of course, they are on the same plane and they never meet. And this line right here is called the transversal. Okay, so this guy right here, I'm going to make that a different color, is our transversal. Okay, so I'm going to make that, I don't know, how about a little red? Here's our transversal. Okay, so we have two parallel lines cut by a transversal, the transversal hitting both blue parallel lines. Okay, we talked about the number of angles that were created, and so I'm going to put a point here, put a point there, and I'm going to put a point there so I can measure a little bit easier. And as far as the numbers we used, I believe we had called that 1, 2, we called that angle 3, we called that angle 4, and we called that angle 5, angle 6, and we called that 7, and we called that 8. Okay. And then what we did is we measured a whole bunch of angles, and I asked you to basically measure all of them and come up with angles that are either equal or supplements. And so I'm going to measure them quickly right now. So I'm going to measure angle 1 and measure. I'm going to put that right here in angle 1. I'm going to measure angle 2, which will be supplementary to angle 1, right? I'm going to measure angle 3, of course. Put that right there, angle 3, which is going to be supplementary to 2, or equal to 1 by the vertical angle theorem. And I'm going to measure angle 4. Okay, and of course that's not too bad yet, but it gets interesting when I move up along the transversal to angles 5, 6, 7, and 8. So here's what's happening at those 4 angles, right? And let's measure angles. Let's hop right along the transversal and look at angles 5, 6, 7, 8. So I'll measure angle 5. I'll measure angle 6. Oh, wow, that's interesting. How about that? Angle 6, of course, you guys already did this today. Oops, nope. Yabba dabba doo. I'm going to measure angle 7. And then 8. So here comes angle 7. Boom, boom, boom. And I'm going to measure angle 8. Boom, boom, boom. Here's angle 8. All right. So you guys did this today, and what we can do is we can move these transversals around, and the same pattern seems to occur. So I'm going to highlight those angles that are equal. And it looks like we have a lot of angles that are equal or supplements. And here's another group of angles that are also equal in measure. And so what we came up with is the fact that any two angles, as long as the lines are parallel, and it doesn't matter where that transversal is, we still have 4 angles that are equal, and another 4 pairs of angles that are equal to themselves, but supplementary to the first 4 as well. So here's what's happening. Okay. First of all, we have to name some angle relationships, and we're going to start with, if these are 2 parallel lines, and this red guy is our transversal, it's ripping right through those 2 parallel lines, then any 2 pairs of any 2 angles can be described as an angle relationship. And so I'm going to first start with the first alternate interior. And alternate interior angles are on alternate sides of the transversal. Right? So alternate, here's our transversal. So if one's on the right, the other's on the left. And interior means they're kind of bounded between. They're in the inside of these 2 parallel lines. So angle 5 and angle 3 are a pair of alternate interior angles. They're on different sides of the transversal, and they're on the interior. They're between the 2 parallel lines. Okay. So 5 and 3 angles, of course. And there's one more pair of alternate interior angles, and those would be angles 6 and 4, right? So angles 6 and 4 are also on opposite alternate sides of the red transversal, and they're in the interior, inside those two parallel lines. So 5 and 3 are a pair of alternate interior angles, and 6 and 4. Okay. Another type of angle relationship is called corresponding, and corresponding angles look like this. Okay. Corresponding angles make an F. So if one is up here, okay, then the other would jump here and be right down there. So 8 and 4 is one pair of corresponding angles. Corresponding angles are really same side, kind of jump over angles, but that's kind of confusing to say, so we say corresponding angles. So angles 4 and 8 are corresponding as far as their relationship is concerned, right? 4 and 8. And so another corresponding pair of angles would be 5 and 1, right? They're on the same side of the transversal. You work down, jump across, boom. So 5 and 1, another pair. Another pair of corresponding angles on the other side of the red transversal will be 7 and 3, corresponding. And the final pair would be 6 and 2. 6 and 2. Okay. So here we go. Here's angle 6, 2, corresponding. Okay, same relationship as 7 and 3, also corresponding. Same relationship as 8 and 4, corresponding. Same relationship as 5 and 1, also corresponding. Okay. Here's where the F comes into place. Can you see that? So here's angle 5 and 1, one pair of corresponding angles. So here comes the F. Come right down the transversal, and then here's the other side, right? So there's your F. It creates the two corresponding angles. Same side, jump over angles. Okay, there's one other type that I'd like for you to understand, and that's, I guess we have alternate interior. We could have same side interior. Okay, same side interior kind of describes where they are. So on the same side of the transversal, okay, so if they're both on the right, and they're in the interior, right, between the two parallel lines. So these two angles, 5 and 4, are same side of the red transversal. They're on the right, and they're in the interior, they're between. Right, so angles 5 and 4 are a pair of same side interior angles. Okay, and of course there's one other pair on the other side, the left side of the transversal, 6 and 3. Okay, same side interior, 6 and 3, 5 and 4. Okay, I guess there's one more I shouldn't neglect. Those are called same side exterior. We can also have alternate exterior, etc., etc., etc. Okay, so these are just angles to keep in mind, and we can work from really any of these three. These are the three biggies. And these two, same side interior, alternate exterior, are described by the way in which we name them. So alternate exterior, what would be one example of alternate exterior angles? Well, 2 and 8, right? Different sides of the red transversal, alternate. Exterior, so if in between the two parallel lines interior, then exterior is on top or below of the two parallel lines. So 2 and 8, same side, alternate exterior. 1 and 7 are another pair of alternate exterior. Okay. 2 and 8, 1 and 7, and we may as well finish it off. Same side exterior. Same side exterior. You have 8 exterior, interior is 5, interior is 4, and then same side is 1. Right. So 8 and 1 would be same side exterior. Same side transversal, both exterior. 7 and 3. Okay. So let's formalize that. 8 and 4, 7 and 3. Okay. Now, what we found today was as follows. Okay. Number 1, if those lines are parallel, if we have parallel lines, then some things happen. Number 1, alternate interior angles are, well, let's go see. Okay, alternate interior. So I'm looking at right now angles 6 and 4. What do you know? They're equal. How about angles 5 and 3? What do you know? They're equal too. So that's correct. Alternate interior angles are equal as long as the lines are parallel. Number 2, corresponding angles. Well, corresponding angles make those F's. So here's a pair of corresponding angles. How about angle 8 up here? Jump over, same side, bam. Ooh, those are equal. Here's another pair of corresponding angles. Oh, they're equal. How about these corresponding angles? Oh, they're equal. Those corresponding angles. Oh, they're equal. What if you move the transversal? Oh, they're still equal. What if we move it back? Whoa, still equal. Okay, so if the lines are parallel, corresponding angles are equal. That's correct. Okay, and the third one I want to look at is the same side interior angles. So, let's look at our diagram. Same side of transversal interior, boom. Well, those aren't equal. Let's add them together, see what we get. Oh my gosh, they equal 180 degrees. How about that? Same side interior angles? Ooh, supplementary. What if we change that? Move the transversal around. Well, the two angles are changing, but you know what? They're still supplementary. So that's correct. Same side interior angles are supplements. Okay. So basically, if we have this diagram, okay, two parallel lines cut by a transversal, okay, as long as the lines are parallel, okay, then any two angles have to be congruent or equal. Excuse me, equal or supplements. Alternate interior angles are equal. Okay, so 5 and 3 will be equal. They're alternate interior angles. 4 and 6 will be equal. Alternate interior angles. Corresponding angles will be equal. 8 and 4. 5 and 1. 7 and 3 corresponding as well. Equal. And 6 and 2 corresponding. Equal. As long as the lines are parallel. Okay, and same side interior, 6 and 3, yeah, those add up to be 180. And how about these guys? Yep, 5 and 4 add up to be 182. Okay. So, we're going to work with this tomorrow. Good work today in class. Have a great day.